Okay, class. So if we're going to measure, and what you're going to do is you're going to measure a mechanical advantage. And there's mechanical advantages, levers, or wheels and axles all over your house. So what you're going to do is find one. I have found a can of 7-Up, or a Sprite, and the flip top is a lever. So I'm going to need to find out a few things. I'm going to need to find out the distance from the effort to the fulcrum, the distance from the resistance to the fulcrum, and then calculate the ideal mechanical advantage. I can use whatever I have to measure those distances, like the protractor or a ruler or even a dowel caliper. I could even use the grids on some graph paper because it's a ratio. The formula is a ratio. I don't need anything really because those units are going to cancel out as long as I'm consistent. So let's take some measurements. Now remember, it doesn't matter what units, but I'm looking at this thing and it appears that my flip top is almost exactly 1 inch from end to end. So I can split this up into 1/16 of an inch, and I need to figure out where my fulcrum is. Well, the fulcrum, if I start pulling on this, or even if I actually crack it open, you see that the fulcrum is going to be right here at the edge of that dot in the can. I pop it open. The resistance, that's this thing, the seal, and my effort is what I'm lifting up on. So I can see that there's my pivot point. My fulcrum is right there. So let's take some measurements. So looking at the fulcrum, from the fulcrum to the distance of resistance, it's exactly 3/16 of an inch. Now, if you're not comfortable with inches, use centimeters, but because I measured this whole thing and it was exactly an inch, that makes it easy for me. So I'll show you on the paper. The distance from the resistance to the fulcrum was 3/16 of an inch, right? The whole distance was 1 inch. And we're talking about this thing right here. So this whole distance I measured and it was 1 inch. And then I measured from the fulcrum, which was right here to here, was 3/16. So that means that my distance of effort was, what? 16 minus 3 is 13. 13/16 inches. So then I just plug those in. Distance of effort, 13/16 of an inch, divided by distance of resistance, which was 3/16 of an inch. 16 over 16 cancel. Inches over inches cancel. Equals 13 over 3, or that is 4 1/3 to 1. That's my mechanical advantage, my ideal mechanical advantage calculated. And now you're going to do this with anything you can find around the house. Bottle openers, can openers, a faucet outside is a good example of a wheel and axle. You're going to explain it to me, and you're going to show your work, and you're going to submit your video.